Hello students, let us discuss some of the text solved problems given in the page number 41 and 42. These are actually based on the mole concept. So let us discuss these questions and its answers. Before discussing the problem related to mole concept, first let us discuss some important formula. The two important formula which we need to discuss here, for that we need to write a representation for the sum terms like number of moles we are representing in small letter n, given mass we are representing in small m, molar mass we are representing in capital M, the given number of particles are represented in capital N, and the Avogadro number, that is a constant number, we are representing in terms of capital Na. Now we'll be using these letters to make formula. First we are writing out the formula for number of moles in relation with mass. Listen here, moles and mass, the relation formula is this formula. That is, number of moles is equal to given mass by molar mass. Given mass, that is small m, molar mass capital M. So N is equal to small m divided by capital M. So this formula is actually giving the relation between the number of moles with the mass, that is given mass and molar mass. So if you learn this formula, from this we can generate three formulas. Like if number of moles, if we want to find out, you will be using this formula. If the given mass is to be find out, so how we find out m, small m is equal to that is n into capital M. So you can generate the formula in this way. For example, if a given mass and the number of moles is known to us, if these two are known to us, then how you find out capital M? Then capital M is equal to small m divided by n. So we have to take this on the side and this n will come down. So the formula will become capital M is equal to small m divided by n. So you can, three formulas can be generated from this. Next, if the number of moles and the given particles is there, so we will be using this relation. Number of moles is equal to given number of particles divided by Avogadro number, that is capital N divided by Na, that is equal to number of particles. If we want to find out the number of moles and given number of particles and Avogadro number is a constant value, so we use this formula. If we want to find out capital N, that is number of particles, then the formula generated will be N into Na. So this is the formula generated, that is N is equal to N into Na. So if you want to find out the number of particles, we'll be using this formula. So if you learn these two formula, we can solve the problems related to number of moles, mass and the particle relation. Example 3.3. Calculate the number of moles for the following. Here the two questions are given. So let us do this one by one. First one. Calculate the number of moles for 52 gram of helium. So what is you need to find out here? Number of moles have to be find, and what is given to in 52 gram of helium we have to find out number of moles. So what is actually the terms we are using here? For number of moles we represent it with small n. Number of moles can be represented in small m. Given mass, that is represented in small m. Molar mass will represent in capital M. And the number of particles that we are representing, given number of particles we will represent with capital N. And the Avogadro number, that is represented by Na. So these are the representation which we are using for solving the problem or for making the formulas. So now let us do this problem. What is given here? Helium is given, 52 gram of helium, that is the given mass. 52 gram of helium which is given the question, that is a given mass. So what is given mass here? That we are representing with small m. So given mass, that is equal to 52 gram of helium. So molar mass actually we have to remember the molar mass for helium. What is the molar mass for helium? That is equal to 4. That is capital M is equal to 4. Molar mass for helium is equal to 4. The number of moles, the formula is to be used, that is N is equal to M by M. That means small m divided by M. So N, that is number of moles, is equal to given mass by molar mass. So find out what is the given mass here. 52 is the given mass, 4 is the molar mass. When you divide it, you will get 13. So what will be the number of moles here? That is the 13 moles of helium. So instead of saying 52 gram of helium, we can say 13 moles of helium. So that is the answer. Next part of this question. 12.044 into 10 raised to 23 number of helium atoms is given. You have to find out the number of moles. So here the number of particles are given. So in that case, what will be the formula for finding out the number of moles? The formula is this one. That is small n is equal to capital N divided by Na. That is the given number of particles divided by the Avogadro number. So what is the given number? What is given to us? This value of number of particles is given. That means this much number of helium atom is given. So that will be taking here divided by Avogadro number, that is a constant number. That is value is equal to 6.022 into 10 raised to 23. So when you solve it, you will get the answer, that is 2. So what is the answer you are getting here? That is 2. So 2 is the number of moles which having 12.044 into 10 raised to 23 number of helium atoms. Question number 3.4, example 3.5. Calculate the mass of the following. Now we have to find out the mass for the following case. Let us do this one by one. First part of this question. Calculate the mass of 0.5 mole of nitrogen gas. Here, the number of moles of nitrogen gas, that is a molecule, is given 0.5 mole. We have to find out the mass of 0.5 mole of nitrogen gas. So, we need to use a formula, that is mass is equal to molar mass into number of moles. How we got this formula? Because we have already learned a formula, number of moles, that is N is equal to small m by capital M, that is given mass by molar mass. So if we are finding out the given mass here, that is small m is equal to how much? That is N into capital M. So we are getting this formula in this way. So substitute the values here, that is capital M is the molar mass, that is the molar mass for the nitrogen gas, that is a 28 gram into 0.5 mole, because in the question it is given 0.5 mole. So that is equal to 28 into 0.5, that is equal to 14 gram. Therefore, the mass of 0.5 mole of nitrogen gas is equal to 14 gram. Here N2 is taken, that is it is for N2. So we have to take the molar mass for N2. So we are getting the answer 14 gram. Second part of this, calculate the mass of 0.5 mole of nitrogen atom. We have to find out the mass. So what is the formula for mass? Mass is equal to molar mass into number of moles. So that is small m is equal to capital M into N. How you got this formula? We already know the formula, that is N is equal to small m by capital M. So how you find out small m? That is multiply N into capital M, that is equal to small m. So this formula you have actually generated from this formulate. So small m is equal to capital M into N. That is 14 is the molar mass for the nitrogen, that is nothing but the atomic mass in grams, gram atomic mass, that is 14 for nitrogen. 0.5 is given in the equation, so that is equal to 7 grams. So 7 gram is the correct answer. Third part, calculate the mass of 3.011 into 10 raised to power 23 number of nitrogen atom. Here number of particles are given to us and we have to find out the mass. So what will be the formula you will be using? The formula will be using, that is the number of moles you have to first find out. So how we find out number of moles? When the particle is given, the formula is number of moles is equal to given number of particle divided by Avogadro number. So that is N divided by Na. This formula we have already discussed in the previous question. So what is the number of particle given? This is the number of particle, that is 3.011 into 10 raised to power 23 divided by Avogadro number, that is a constant number. So from this you will be getting the number of moles. So as we need to find out the mass, so we have to use the formula mass is equal to molar mass into the number of moles. So when you do this one, here the number of moles we have already find it out here. So that value we have to take here, number of moles. So that is 14 is the molar mass into N, number of moles that we have find it out here. So that value will be taking here. So when we do the calculation, we'll get the answer, that is 7 gram. So 7 gram is the correct answer. Fourth one, calculate the mass of 6.022 into 10 raised to power 23 number of nitrogen molecules. So we have to find out the mass for this much number of nitrogen molecule. So first we will be writing the formula for number of moles. Number of moles formula is equal to N by Na, that is the given number of particle divided by Avogadro number. Because here we are finding out the mass, so mass is equal to, we have learned the formula, mass is equal to molar mass into number of moles. So in the place of number of moles, we'll be taking this value. So that is N by Na. So when you substitute the values of capital M, that is molar mass, it is asked for nitrogen molecule. For the nitrogen molecule, what will be the molar mass? 28. N is given this much, that is this value is given. Avogadro number is this. So here Avogadro number and given number of particle is same. So that is actually, we can say it is equal to 1 mole. So 1. So 28 into 1 is equal to 28 gram. Units plays a very important role. When it is asked for mass, you have to represent the unit in grams. So the answer is 28 grams. Example number 3.5. Calculate the number of particles in each of the following. Here we need to find out the number of particles and the 3 questions, sub questions which is given here. So let us solve this one by one. First part of this one, calculate the number of particles in 46 gram of sodium atom. That means the mass is given, that is 46 gram. That is called as a given mass. So given mass, that is small m, is equal to 46 gram. The question is, we need to find out the number of particles. So what will be the formula? The number of particles, here it is an atom, therefore number of atom is equal to given mass by molar mass into Avogadro number. Actually this given mass by molar mass is nothing but the number of moles. So what we can have the formula, N is equal to small n into Na. That means the number of particle is equal to number of moles into Avogadro number. This we have already discussed this formula. So we are substituting the value of n here, that is small m by capital M. So we'll be getting this formula, that is small n is capital N is equal to small m divided by capital M into Na. What it means? The number of atom is equal to given mass by molar mass into Avogadro number. So when we substitute the values, here small m is the 46 gram, that is a given mass. Molar mass for sodium, that is for sodium the molar mass, actually atomic mass, because here it is an atom. The atomic mass in grams, that is how much? 23 gram. So we are taking that value 23 gram here into Avogadro number. It's a constant value. So after making the calculation, we are getting the number of particles 12.044 into 10 raised to power 23. So this is the answer for this question. Second part of this one. Calculate the number of particles in 8 gram of oxygen molecules. Here the particle is actually molecule. Which molecule? That is oxygen molecule, and the mass is given, that is a given mass. So we are using the direct formula, n is equal to, that is number of particle is equal to given mass by molar mass into Avogadro number. Given mass is actually 8 grams. 8 gram is the given mass and the molar mass is 32. How it comes 32? Because the atomic mass for oxygen is 16 mu. So gram atomic mass 16 gram into 2, that is O2. We are finding out the molar mass for oxygen, that is equal to 32 gram. So when you substitute the value here, you will be getting, after making the calculation, we will be getting 1.5 approximately 1.51 into 10 raised to power 23. So this is the answer for this question. Third part of this, calculate the number of particles in 0.1 mole of carbon atom. Look at here. Here it is given 0.1 mole. So we know that 1 mole of any substance having with 6.022 into 10 raised to power 23 number of particles. So 1 mole of particle means this much number of particles. So 0.1 mole means how much will be the particle? That is equal to 0.1 into this number. So better we can learn this in the form of formula, that is the number of particle is equal to number of moles into Avogadro number. So that is 0.1 into 6.022 into 10 raised to power 23. So when you solve this one, it will be getting 6.022 into 10 raised to power 22 is the answer.